Okay, so you had said something earlier about the ability to prototype.
Yeah.
So when we think about that iterative design process, a lot of times it's rapidly speeding up from print to print or from job to job.
Right.
The ability to try different things in your design. How does that compare with the speed that you're able to do with your 3D printing prototypes with comparison to that of when you have to have something milled?
Well, that really depends on the materials you're using and to what specifications. But I think I was talking earlier about this is the first thing I printed. It's an adapter that adapts a camera to a vacuum chamber. This is not that complicated. It's simple. It was my first one, but it proved to save us a lot of money. Time depends. It's not always faster, usually a little bit faster, but really it's about money in today's age where we have smaller budgets and smaller instruments. The amount of money it takes to take material and machine it, and depending on the material cost is high. Usually it's labor, it's the machinist's time on the machine. If it's something very complex, with machining, you take a block of something and you remove material. It's subtractive manufacturing. And so something very complex with a lot of material removed costs more money. In 3D printing, it's just the opposite. The more complex, more holes and ledges and hog outs there are, the cheaper it is. Because with 3D printing, you're basically paying for how much material it is.
Okay, so that's interesting. So when you think about that additive process versus that of the subtract, right? I see you brought some things with you there.
Sure.
Why don't you talk through us for a little bit here of what kind of process you went through to create? It looks like you have something that might be milled, something that might have been printed, and then interestingly I'm seeing another piece of material that also looks like it might have been milled.
So here we have some examples of a scientific spacecraft instrument component that we were trying to prove and see how easy it would be to 3D print them. This is the original right here, which was turned on a lathe and milled in a machine shop, which cost probably on the order of several $1,000s. And that was part of the stereo mission. So after I got into a 3D modeling program, I printed it out with our inexpensive printer here with PLA, and as you can see, it pretty much cost nothing. And it worked out pretty good. It was mainly just to test my design. Everything lined up really well. Then we had a third-party printing company print this out in nylon. As you can see, it's a lot more detail. Everything lines up perfectly. It fits. It again tested their ability and my ability to model the component. And that cost about $80. And then the ultimate thing was to have it printed out in stainless steel, and this is in a black matte finish. That ultimately cost $750, which is a lot cheaper than having this machine.
So I definitely heard you say cost, the ability to design, and I would imagine, how many times have you designed and actually gone through the prototyping process without even printing? So in other words, as you're going through and looking at, what software are you using right now?
I'm using SolidWorks right now, which is an high-end engineering solid modeling, which isn't always used in more of the educational and 3D printing world. It's a little bit high, but it's certainly nothing wrong with it. It's very precise. Sometimes more precise than 3D printing can be with a homegrown. This is called fused deposition modeling, which is the most common type of printer in the world. But making something much more accurate and out of all kinds of materials. And they're coming up every week with the materials. I couldn't tell you exactly, but pretty much if you can think of it, someone's trying or developing, or it has been printed. So I don't want to say it's the future. It's not the future. It's happening right now.